All right, 8.3, guys, sorry. Supplementary material for 8.3. This stuff is in Alex, but it is not in your textbook, but I still think it's really important, so we are going to just continue on with this. So last time we talked about graphing. F of x equals ax squared plus bx plus c. This is the standard form of a quadratic function. All right, we found the vertex to be negative b over 2a, so we had to work to find the vertex, and then would get the y coordinate would be f of negative b over 2a, and we continued on. We had all that information. We determined if it opened up or down, the axis of symmetry. Now today we're going to talk about the vertex form of a quadratic equation. The vertex form is just if we were to take this and complete the square and put it into a different form. Sometimes it's presented to us that way. That's why we like to work with them. So f of x is equal to a x minus h squared plus k. So this is the general template for the vertex form of a quadratic function. We can also write it in its equation form by replacing the f of x with y. All right, why we do this? Well, again, sometimes it's handed to us in this form. When it's handed to us in this form, we can look at the equation, and whatever two numbers these are, they're handing us the values of the vertex. The vertex is going to be the opposite of this number. So if this is minus h, it's going to be plus h. If it was plus h, it would be minus h. And then it would be the exact value of what's tagging on the end. Now, when we had a quadratic function in this form, we had to work to find the vertex. If it's given it to us in this form, the vertex is handed to us. But now the difference is, if we're given a quadratic formula in this form, we are handed the y-intercept. In this case, this is not the y-intercept. We would have to work for the y-intercept. So keep that in mind. Each form has its advantages. This form, we had to work for the vertex, but we were handed the y-intercept. In this form, we're handed the vertex, but we have to work for the y-intercept. So let's just get used to this form for a minute. So if we were given the equation f of x equals negative 3 x times x minus 6, all quantity squared, plus 12, I would know immediately by looking at this that the vertex of this quadratic function would be the opposite of this. So if it's minus 6, it's going to be plus 6. And the same as this. So just looking at this, I know that the equation of the vertex, the coordinates of the vertex would be positive 6, positive 12. Now we could confirm this by the methods we learned in the last couple lectures, we could FOIL this out. Remember, do not distribute a power through addition or subtraction. So we could FOIL this, distribute the 3, and use that other template. But the process is saying don't bother doing that. Save yourself the work. If it's in this form, let's work with it in this form. So the next example, 2 times quantity x plus 8 squared plus 4. Well, the vertex is going to be, the x-coordinate vertex is going to be what's inside with the x, but change the sign. So negative 8, and then the y-coordinate is what is dangling on the outside. Leading coefficient is still this number out front, so the a value would be negative 3. Here, a would be 2. All right, vertex of this third equation. Well, it's going to be opposite of this is the x-coordinate. Same as this. So the vertex, I know the vertex of this quadratic function is going to be 3, negative 2. All right, lastly, sometimes the easier the problem, the trickier it is to find the answer. You have to think of this as, well, I'm not subtracting anything before I square it. So the x-coordinate of the vertex would be 0, and the y-coordinate would be 4. So if there's nothing being squared with the x, then the x-coordinate of the vertex is 0. So now pretty much every other process that we followed in the beginning of 8.3, we will do here. So let's go through an example. Oops, why do I have 2 of the same one? That's all right. And let's find everything we did for the previous problems. For this example, we're just going to have it in this form. So f of x equals 2 times x minus 4 squared minus 8. So let's find everything there is. So first determine if it opens up or down. So a, the leading coefficient, is going to determine if this opens up or down. So we know that this is going to open up. because the leading coefficient is positive. The vertex, well, we like this because the vertex is handed to us. We didn't have to do any work. It's the opposite of this number and the exact value of what's being dangling on the end. Right? The equation of the axis of symmetry. The equation of the axis of symmetry is always x equals the x coordinate of the vertex. What did we do next? The y-intercept? All right, now be really super careful here because the biggest mistake students make is they think back to what we did in the previous lectures and they say, oh, the y-intercept is -8. That's not true. This is handing us this time the y coordinate of the vertex. Here we have to work for the y-intercept. To find a y-intercept of any equation, you set x equal to 0 and then you stick 0 into the function and get the result. So it's 2 times 0 minus 4 squared minus 8, which is 2 times -4 squared minus 8, which is 2 times 16 minus 8. Wow, this is going to be big, right? And it's going to be 32 minus 8, which is 24. So the y-intercept, now notice that number does not appear at all in the equation, so this is not the y-intercept in this form. We have to work for the y-intercept. It's 0, 24, or just simply y equals 24. So let's work on this a little bit. Let's plot what we have. I know my vertex is at 4, -8, so 4 right here. 1, 2, 3, 4, 5, 6, 7, 8, -8. So here is the current coordinates of my vertex. I know it opens up, so it is going to cross the x-axis, so we are going to have to do that. So there's my vertex. I'm going to draw my axis of symmetry. Just have some idea of how this guy behaves. It'll be helpful when we're trying to plot other points. So this is going to be x equals 4. It's the equation of the axis of symmetry. We worked hard and we got the y-intercept to be 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24 would be up here. Right, so my y-intercept, 0, 24. So I know my y-intercept is 4 steps to the axis of symmetry. So I automatically know another point 4 steps to the right of the axis of symmetry because the y-intercept is 4 steps to the left. So if I go 4 steps to the right of the axis of symmetry, I know another point is automatically going to be 8, 24. So I already have 3 points, so all I need to do now is find where this crosses the x-axis. So to find where it crosses the x-axis, we are going to find the x-intercepts, or the zeros of this function. So to x-intercepts, 2x minus 4 squared minus 8 equals 0. Now it might be your instinct to multiply this out, distribute the 2, and then use maybe the quadratic formula or try to factor. But when it's in this form, think back to 8.1. It's set up in a form that's really nice for us to use. If we can just isolate what's being squared, we can use the square root property. The square has already been completed for us. So I'm going to add 8 to both sides. Again, you may distribute and do it that way, but save yourself the headache. Now I'm going to divide out the 2. So here I added the 8 to both sides. I'm going to divide the 2 out, so I get x minus 4 squared equals 4. Now I have it in the form something squared equals a number. So what I'm squaring is the square root of the number, or what I'm squaring is the opposite of the square root of the number. 4, don't take that yet. All right, so now I can simplify this. X minus 4 is 2. Add 4 to both sides. X equals 6 is one answer. Now this does not involve radicals or i's, so I have to do the algebra on the other side. We can only assume the conjugate if we have square roots or i's left in our answer, and we don't, so I have to do the work here. The opposite of the square root of 4 is -2. I add 4 to both sides, and I get 2. So therefore, my x-intercepts are 6, 0, and 2, 0. Or equivalently, we can just say 6 and 2. Let's see if that makes sense in our picture. 2 would be 2 units to the left of the axis of symmetry, and this would be 2 units to the right. Yep, so that looks perfect. So it's going to be a little rough to draw, bear with me, because it's really super steep. But there's my 5 points. Again, you want to try to save yourself the hassle. Don't multiply this out. It's good practice for solving these equations just by isolating what's being squared and then using the square root property here. Oh no, sorry, I was off. There we go. All right, so now our last important features, our domain. The domain of all quadratic functions, unless otherwise stated, is negative infinity to infinity. The range always depends on the y-coordinate of the vertex. We can see that every point on this curve falls above -8, so all numbers above -8 are represented by -8 to infinity. Here we have a minimum value. Because it's an upside down parabola, it goes as low as -8. If we want to know where it occurs, at x equals 4, but the actual value is the output. And then the end behavior is equal to up to the left and up to the right. There we go. All right, let's try another one. Y equals -4, x minus 8 plus 7. So opens up or down. Leading coefficient is negative. So opens down. Our leading coefficient is negative. The vertex, this is so exciting, it's just handed to us. The vertex is the opposite of this, that actual number. Opposite of that, same as that. Equation of the axis of symmetry. X is equal to the x-coordinate of the vertex. My y-intercept. Now remember, we didn't have to work for the vertex, so we have to work for the y-intercept. So if x is 0, y is equal to -4 times 0 minus 8 squared plus 7. I got this y-intercept to be -249. So clearly that's going to be impossible to graph unless I really, really super duper scale my axes. All right, so let's plot that and see if we have to even work to find the x-intercepts. All right, so vertex is at 8, 7, and it opens down. So yep, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 8, 7 is my vertex. And this is an example, like let's suppose you had this in ALEKS, you're like, how would I ever plot the y-intercept? Well, that would just be a point that you would choose not to plot, and we would choose other values to plot. So it opens down, so I know it's going to cross the x-axis. I'm not going to bother plotting my y-intercept, but I'm going to work on my x-intercepts, because we know there are x-intercepts, so -4. X minus 8 squared plus 7 equals 0. Right, they're not pretty, but again, you can distribute this and just multiply x minus 8 times x minus 8. Make sure you don't distribute the power through addition and subtraction. Distribute the 4 and then use the quadratic formula, but that's an awful lot of work. We could just subtract 7 from both sides, and then we can divide out the -4, and get x minus 8 squared equals -7/4, -7 over -4, which is +7/4. And now the square root property says that x minus 8 is equal to the square root of 7/4, or x minus 8 is equal to the opposite of the square root of 7/4. So don't forget to simplify all radicals. This is the square root of 7 over the square root of 4. Square root of 7 can't be simplified, but the square root of 4 is 2. I'm going to add my 8. 8 plus the square root of 7 over 2 Now, because my answer involves a radical that can't be simplified, I already know the other one's going to be 8 minus the square root of 7 over 2. So I pop this in my calculator to gauge where I'm going to plot it. So that's about 9.3 on the x-axis. And this one is about 6.7 on the x-axis. So again, not nice points to graph. So 9.3 is going to be about right here. 6.7 is going to be about right there. So they look nice, but Alex isn't going to let me plot these points. So in this case, what you're going to need to do is go back to your original equation and plot some points close to this, but don't necessarily characterize important features. So my vertex, the x-coordinate was at 8. I'm going to see how this function behaves at 9. At 9, I'm going to get 9 minus 8, which is 1 squared 1 times negative 4. You should get an output at 3. So at 9, right here, I know I'm at 3. So that's a nice point. So you just have to choose the nice points. So now this 0.93 is 1 unit to the right of the axis of symmetry. So if I go 1 unit to the left, I know that that's also a point. So that's going to be the 0.73. And I promise if you put 7 in here, your output will be 3. Now I'm going to move over. I'm going to try 10. Sticking close to the vertex when it's in this form makes it really nice, gives you nice output. So if I put in 10, I get 2 squared, which is 4, negative 16. Plus 7 would be negative 9. So assuming I did that correctly, 10 is 4, negative 16, it would be negative 9. So at 10, I'm going to be way down here at negative 9. So that's 2 units to the right of the axis of symmetry. So if I go 2 units to the left, I'm going to be at 6, negative 9. And there we go. We have 5 nice points to plot. We can still identify the important features. We can't see the Y-intercept because it's so far down here. Domain, all real numbers. Range is, well, it's everything below 7. So if it's below the value of the vertex, we start with negative infinity. End behavior. Up to the left. Oh, no, don't do that. Yeah, down. It's pointing down. Down to the left. Down to the left. And then down to the right. Woohoo. All right, kids, that gives you lots of problems to work on. If you have any questions or concerns, I'll be more than happy to go over any of this material with you. Oh, good. I did get your Chapter 8 homework. So your to do, 8.3. To do. I will post this on Blackboard. Read 8.3 in the text. Now your text only covers quadratic functions in standard form, which I'm not happy about, but Alex does get the rest of this material in Vertex form for you. Exercises in your book. Remember, the more you do, the better you're going to get at this. 1 to 13 odd and 17 to 55 odd. Alex. We can now do 8.1 to 8.3 topics. You had last night, you only had a little bit due a couple nights ago. So for Wednesday, for 8, you want 60% plus or 5+ hours. Remember, you have a test in less than 2 weeks on Chapter 8. There's only 4 sections, so get busy. So for 4:15, you want 100%, right? And don't forget that you have exam number 3, Chapter 8, on Thursday, 4:16. Super duper important. Please go back, download, lockdown browser. And Respondus. We added this. You have to add this ASAP. Do not message me late Wednesday night on the 15th or on the 16th and tell me that you couldn't download this, because you won't be able to take the test. All technical difficulties need to be handled as soon as possible. All right, that's it. I'll post this to do. and look forward to 8.4 next week. All right, guys, stay safe. Talk to you soon.